So here is the calculus test review about area between functions, average value theorem, and fundamental theorem of calculus. For page 17, you definitely need some more paper. This is not enough room. So get some scrap paper or notebook paper. One says write the integral and sketch the graphs. So I'm going to start with the graphs. You need a calculator. It's helpful. I like to put f of x in y1 and g of x in y2. That way, if I keep it consistent, and it matters these points of intersection, and it matters which graph is on top. So I see that the parabola, which is f of x, is on the top, so that one is going to be minus the g of x. If you wanted, you could do the actual function. Oh, you can't see what I'm writing. Sorry. There we go. So since the f function's on top, it's f minus g, because you always do top function minus the bottom function. Well, the f equation in the problem is 2 minus x squared, and the g is x. We always have to write the dx to show that we're using the integrating with the x. Now I have to find these x values. So in the calculator, I'm going to do second trace, choice 5 is intersect, and hit enter 3 times on the location. And I only care about the x. So the far right side is 1. I'm going to do that again and find the left point, and that's going to be the bottom value of my integral. And that's at -2. So now in the calculator, because I don't have to use the fundamental theorem of calculus, I can do the integral. So I like to do the math, num, and then at the bottom, oh no, I think it's under math, sorry, just math, at the bottom, fn int. I have the old kind of calculator, so I have to do the comma version like this. If you have a new calculator, put the pieces in the right part of the function notation. So to get the y1 and the y2, you do the vars button, you arrow over to y vars and do function, and then you pick your y1 or y2. So the integral is 4.5. All right, B. To start over again with my calculator. Graph. All right, so we've got this parabola and this parabola. So the negative x squared, the negative quadratic, is the reflected parabola. So that is the graph that's on top. So when I do my integral, that's going to be g of x minus f of x. So that's my y2 minus y1, the order I did it in the calculator. To get the points of intersection, second, calc, intersect, hit enter 3 times. So that it starts at 0 on the left, 3 on the right, I like to just type over. I find that easier. So I did second enter to get back what I typed. You could do the whole thing again from the beginning, and we get 9. Okay, for C, typed them in. So g of x being 0 is the x-axis, and then here's the other graph. So we actually have 2 pieces. So I need 2 different integrals when I go to set up my answer. So the first one's going to be this left piece. Let me find, oh, and so then the top function is the cubic, which was f. So this one's going to be f minus g. And then it switches, so this is g minus f. So getting all of my points. I've got -1 over here on the far left. Oops, sorry, you can't see my calculator. Zero in the middle. +1 on the far right. And now I need the individual values. Oh, I didn't mean to clear that. Sorry, I just cleared my y1. Okay. Math, fn int. So I'm going to do y1 minus y2. Now you'll know you've done the wrong order of your y1 and y2 or your f and g if you get a negative value. So that's 0.75. So now I'm going to do y2 minus y1. Oops. That gives me 0.75 for both my values. So when I add them up, 1.5 is the final answer. All right, lastly for D, let me graph it here. Okay. So I've sketched that on my separate paper. This one was F and this one was G, I think. Yes. So again, I'm going to have two separate graphs. In the first one, F is the higher function, and then the second one, G is the higher function. Then I need these three intersection points. Oh, it's nice to go left to right. So the furthest left is -2. Looks like this one's at 0, but let's check it. It is. And +2. Okay, so the first one is F minus G, which is my y1 minus y2. If you hit second enter multiple times, it scrolls through what you were just typing. So like when I hit second enter the first time, it's my last typing. If I hit it again, it's before that. If I hit it one more time, I get back to that order, which is what I want for G minus F. So the final answer is 24. Okay, part 2, find the average value. Well, you have to remember the average value formula. It is 1 over b minus a times the integral from a to b of the function. It is going to be just a number. So that's 1 over 2 minus -2 times the integral from -2 to 2. Use your calculator for the integral value. You can do 2 minus -2 in the calculator if you really want as well. Okay, math, fn int, 6 minus x squared, comma x, comma -2, comma 2. So that's going to be times 1/4 For a final answer, let's do it as a fraction of 14/3. Okay, B, and do it again. 1 over 2 minus -1 times the integral from -1 to 2. This is 1/3 times. I should just type it again. Math, fn int, 1 plus x squared, comma x, comma -1, comma 2. 6. 1/3 of 6 is 2. All right, for C, that is 1/2 times. If I don't trust my typing, you could put that function in y1 and then do y1 comma x comma 0 comma 2. Oh, it's thinking. It's not really repeating. I'm gonna take that out. So then do times 1/2 is 1.33. And it's not going to change to a fraction because of the radical. And D, so I'm going to calculate the integral. That's 4, and 1/2 of 4 gives me 2 as the answer. All right, for part 3, we have to do, 3 and 4 go together. Okay, we have to do the fundamental theorem of calculus. So for A, the antiderivative of 1 over x to the 3rd. Well, you can't do that when you have a variable in the denominator. So that's x to the -3rd. Okay, the antiderivative is add 1 to the exponent divided by the exponent plus c, because there is no value. Oh, I'm sorry, I shouldn't have said the fundamental theorem of calculus. It's just the normal antiderivative. You have to do the plus c because there's no values. The fundamental theorem is when we have the definite integral. My apologies. All right, I'll do 3 here, and then I'll do 4 down the right side. You could make that look nicer. We're going to put that back in the denominator. And that is our antiderivative in A. Okay, B. Again, we have to make the square root of x better, so we're going to make it a power. Now we're going to add 1 to the exponent. So that's x to the 3/2 divided by 3/2 plus c. Well, we don't like to divide by 3/2, so we will multiply by the reciprocal. And there is our answer to B. All right, C is getting nicer. Add 1 to the exponent divided by the exponent. Add 1 to the exponent divided by the exponent plus c. And there's really not much more you can do to that. And now for D, the integral of x minus 1 to the 4th is going to be x minus 1 to the 5th over 5. Oops, plus c. And the reason we can do that is because if I make, well, let me show my u I need more space. Let me show my u substitution. If I have x minus 1 to the 4th dx, we can't just do the normal power rule because you have a function in a function. So we say let u be x minus 1. See, du dx is then 1. So that means when I substitute into my integral, I get the u to the 4th dx, and that's a mix. Well, we can't do a mix. So instead, I have to replace dx. So I come back over here and I say, well, what does dx equal? So if I move that to the right side, dx is du. Well, that's convenient. So now I can do the antiderivative and then substitute u back in, and that's how I got x minus 1 to the 5th over 5 plus c. Okay. Now part 4 is substitute in these values to the antiderivative. So f of 1 is negative 1 over 2 times 1 squared plus c. So that is negative 1/2 plus c. B is f of 1, 2/3 times 1 to the 3/2 plus c. Well, 1 to anything is 1, so that is 2/3 plus c. F of 3, 3 times 3 to the 5th over 5. Minus, I'm going to run out of room, 5 times 3 to the 3rd over 3, plus 3 squared over 2 plus c. Definitely need a calculator for that. I want to make sure the calculator does my order of operations correctly. Plus 9/2. So that is 10,000 or 1,053 over 10 plus c. That doesn't look right. Maybe it is. Let's see, maybe I have a typing problem. Oh, that's right, but I wrote it on the answer key as 105.3 plus c, because that looks way better. And lastly for D, it says f of 2. So 2 minus 1 to the 5th over 5 plus c. So you will have a plus c in these answers. Well, that's 1 to the 5th, so 1 over 5 plus c is the final answer there. And now, the fundamental theorem of calculus. So we have to find the antiderivative, then we have to substitute in the values from the definite integral. So here we go, 5a, integral from 1 to 4. Okay, add 1 to the exponent over the exponent. But I don't have a plus c now. Instead, I do the bracket from 1 to 4. So the fundamental theorem of calculus says we substitute in the top number minus substitute in the bottom number. Now I'm going to use my calculator. Sorry, my pen tip got pushed in. I'm finding another pen. Okay, so that's going to be 4 squared divided by 2 plus 4. So this is 12 minus 1/2 plus 1 is 1.5. 12 minus 1.5 is a final answer of 10.5. So you could check with the FN int and actually have the calculator calculate it for you. But if it says use the fundamental theorem, I need to see the antiderivative, see the values plugged in, and see the final answer. Now, 1 over x is special because you can't do the add 1 to the exponent, you would just get 0. So if you look at your formula sheet, or you have to remember that the derivative, what did we take the derivative of to get 1 over x? And that was ln x. So the derivative of ln x is 1 over x. So the antiderivative of 1 over x is ln. So then this is going to be ln of 2 minus ln of 1. The ln of 1 is 0. The ln of 2 is 0.693. So 0.693 is the final answer on the answer key. All right, C. Oop, just x. All right, so the antiderivative, add 1 to the exponent divided by the exponent. Add 1 to the exponent divided by the exponent, and then the constant becomes x from -2 to 3. I'm going to simplify this, and we have 2x to the 4th plus 3 halves x squared plus x. We're going to substitute in 3. Substitute in -2. And then we could type all that in to get the final answer. Or you could do fn int of the original, and you would get 142.5. And last but not least for D, I'm going to do that right on here. X to the 3rd over 3 minus x from 1 to 2. So that's 2 to the 3rd over 3 minus 2 minus 1 to the 3rd over 3 minus 1. That's not too bad to type in. So we get 8/3 minus 2. 1/3 minus 1. Minus a negative is plus, so we get 4/3 as the final answer.